では定刻になりました。まだ全員申請された方が全員いらしてはおりませんけれども、これから始めます。今日はイングリッシュ英語のフォーラムになります。So from now I will speak in English. So today is the fourth forum of Graduate School Business Administration K University Grand Design by Japan. And today's topic is innovation in global perspectives. We invite three prominent and renowned speakers, and I will introduce each just before the presentation. And the main theme is innovation in global perspectives. Lately, Japanese people talk about innovation is necessary, but innovation from the point of all Japan efforts. So that is the strength of Japanese innovation, but at the same time, that is a weak point of Japanese innovation because they are focusing on Japan itself. So we invite the three speakers who worked and who studied, who researched in Japan, but background is foreign countries. So we need global perspectives in innovation. That is the reason we invited these three speakers. The first topic is, as I mentioned, Professor Helmut Prendinger. He will talk about the drone-based service. So that might be very highlighted earlier, and it's very interesting. And the second speaker is Dr. Staff, and he will talk about the service management from the, based on his comparative study between Japan and Germany. So that might be global perspective in terms of the innovation in the field of the service management of manufacturing companies. And the third speaker is third speaker is Mr. Ashok Lloyd. He's the founder of Stay Cool and Japan Edge Fund, and he is doing his business practice very aggressively to promote Japanese innovation in the framework of global situations. So his new idea to import the special devices to streamline the home appliances. So that is his new, the latest effort he is currently engaged. So that service will announce 1 week from now. So 1 week before, we will listen to that kind of the new service. So that might be very interesting. So Professor Prendinger, please.
Yeah, Andegawa-sensei, thank you very much for your kind introduction. And also I would like to thank you for providing me this opportunity to talk to this audience here. This is a great pleasure and honor, and I hope I can get your interest in what I'm now very much focusing on, which is service innovation by drone network and software. So I am working at the National Institute of Informatics. We claim that we are the only research institute in Japan that focuses entirely on all aspects of informatics, including networking, software, and multimedia content. And our hope is that we can create future value, and I will talk about future value creation today as well. Now, as you know, informatics, or more precisely IT, has many success stories, and everyone knows them and repeats them all over. There's Amazon, Rakuten on internet-based retail. There's Google on internet-based services, Facebook, social network service. and a recent one, a transportation network service called Uber. So what I try to do today is to draw your attention to a new kind of service, which I call a drone-based service. This slide here shows a figure from NASA, actually, and it indicates what kind of services you can imagine in the aerospace, in the drone space. There's, of course, delivery, there's search and rescue, there is surveillance, agriculture, and so on. So what NASA tries to do is they want to regulate and exploit what they call low-altitude airspace. And this is actually not much worked on. So we know very well the ground space, infrastructure, buildings, the vehicle network, and so on. We know about high-altitude airspace, where the big planes fly, but little is known about low-altitude airspace. And we believe that soon it will be low-altitude, high-density airspace. So there's a lot of room for services. Now, my big vision is called the drone net. I want to establish the drone net. So the drone net means that anyone from anywhere can dynamically recruit local sensor and actuator resources for whatever their important purposes are. In the good times, this would be cargo, surveillance, and sensing, ubiquitous sensing. And in the bad times, this would be disaster response, response to some emergencies, and so on. So this can be summarized as drone as infrastructure. Now, my vision has a very traditional architecture. It's a cyber-physical system. As you know, there is the physical space and the cyberspace. So people know that the cloud, for instance, they have some applications running. It's processed in the cloud and provides value back. So in this picture, there are 3 levels, actually. The cloud level, this is about storage, data analytics, processing, networking. There is the device level. This is a well-known, everyone now has a smartphone they carry around. So the cloud level and device level are already well established. So what I'm introducing here is another level which is called the drone level. Drone as infrastructure, a network of drones. And I expect the services coming from this drone level. So to make it very simple, we can say the internet connects everyone to information, the drone net connects everyone to physical goods and information. That's as simple as it can get. Now, I had a previous talk and I noticed that I should presumably clarify what we are doing and especially what we are not doing. So what we don't do is the hardware. So I keep talking about drones, but actually we are not developing any drones. So we just communicate and collaborate with a Japanese drone manufacturer, and they do the drones. So drone is about robotics control theory. It's about reliability. It's about sensors. It's about battery, payload, and so on. So many questions I get are actually hardware questions. People say, well, I mean, there's a drone, that's fine, but the drone cannot fly that long because of the limitation of the battery, or we can only put limited sensors, and they are not that reliable yet, and so on. So my response to these comments might be, I don't worry about it. This is going to become better anyway. So drones going to become more reliable, they're going to fly longer, and so on. So this happened with many things, like the computers are becoming cheaper and better, the smartphones become cheaper and better, the cars, everything. So this is what I don't worry about. So what I'm interested in is how we can use the drones to provide a truly useful service. This is a question for the software, not the hardware. And we believe that artificial intelligence is going to be a main driver for making a truly useful service. So artificial intelligence relates to effective human-machine collaboration, in this case, humans supervising multiple drones, automatically allocating drones to various sites for situational awareness, and recently, very important, machine learning, specifically deep learning, which allows us to automatically recognize objects in the environment. So this can be used for collision avoidance, or in a disaster case for automatically identifying people in need. So what I'm mostly talking about would be the software part, or what we as a lab working about is the software part. Now, since service innovation is part of my title, I looked up Wikipedia and I picked one explanation, and that's the theory from Tuss den Hertog, and he identifies 4 dimensions. There's the service concept, the client interface, service delivery system, and technological options. So service concept is about the new value proposition. In our case, this would be more effective delivery, ubiquitous sensing. The client interface connecting the service provider and the customer, we can imagine very simply as a smartphone app where you recruit the service. Service delivery system, this is about transport innovation. I think this DroneNet can innovate transport in terms of delivery of goods, food, and medicine. And technological options relates presumably to different sensors, different payload you can actually attach to this drone. So today I will be mostly focusing on the service at a very high level, but I would also like to show you that very practically we actually doing the experiment in the real world, and this is a simple aerial health system which we realized in Guma prefecture on a golf course, because it's difficult to find a place to fly. So I will show this now. Please read the labels, the captions. Right, so this application was actually inspired by a professor at the Indian Institute of Public Health, who is also a collaborator. And this collaborator actually introduced me to Anegava sensors. So we wanted to establish such thing in India. However, currently we do not have a permission to fly in India. So we made just a simple test in Japan. So we're still interested to do this, but actually it cannot be done in India at this time. Now, I will move on to business models. So I'm from informatics, but now I would like to talk about the business models. Now, about the drone business, this is emerging technology, is a very new topic, so we actually don't have so many data yet on the drone business and the drones itself. So what we do is we claim that cars to some extent are similar to drones, and we believe that we can carry over the business models that work for the cars to the drones, and this is what we try to do. The assumption is based on a certain similarity between cars and drones. So in terms of the usage by individuals, the car brings you from A to B, and the drones can bring goods, items from A to B. The frequency of usage in the case of the car is low, so only 5% of the day the car would actually be used. And projecting the usage of the drone, it might be a similar figure. So we use the drone for the groceries and then errands and so on, but not all the time. Cost of ownership in terms of the car, it is high. For the drone, it's low. Drones are actually pretty cheap. And other usage are related to sensing. So I'm talking about frequency of usage, low, price, high. So this already indicates or suggests that we want to target some kind of share economy business model. So I'm starting from the car. So there are two examples. Zipcar is a car rental business model. So basically, Zipcar owns cars, and they're spread around in the city. And using your smartphone app, you can reserve the car. You go to the car, and there's a mechanism. You can unlock the car, use the car, bring the car back to the same location, pay by the hour, and that's the business model of Zipcar. A smarter version of that is Uber. I think Uber got lots of attention, including very negative attention recently, but the idea I think is very smart. Uber basically connects owners of cars and customers. So some people can just say, okay, I'm going to be a taxi driver today, and people who need the service can just reserve the driver. So it's a kind of a driver rental. So in the case of Zipcar, they actually have to own and maintain the cars. In case of Uber, they just make an application, a smartphone app to connect. And here, again, they don't have to own the cars, and that's what I think is pretty smart. Now, I would like to carry this one-on-one to the drones, because it would make sense for both styles, the Zipcar style and the Uber style. So a Zipcar style drone net would indicate a network of company-owned drones plus pilots. So I always mention the pilots as well. Of course, the future vision is that drones can fly autonomously. They don't need a pilot. However, currently by legislation, we always need, for every drone in the air, we need a pilot looking after it with the line of sight. But other than this, here the customer might just recruit a pilot, paying a fee and a drone, and can use it for what I call everyday normal situations, such as precision sensing in agriculture, get the right data at the right time from the right place, delivery of goods to people, such as Amazon delivery, bringing medicine, food, and so on to the elderly people, and maybe even personalized tourism. So this is a drone at Zipcar style, where a company owns the drones, and customer can just dynamically recruit them. The other version is Uber style. Here we are talking about a network of privately owned drones and pilots, and we can recruit them dynamically from the private drone owners. So this, I believe, would apply to normal situations and exceptional or disaster situations. It's a kind of a crowdsourcing. And not with the drones, but with the smartphones, this is already happening. NHK has a portal, so if some disaster happens, people are encouraged to use their smartphones and provide footage of the disaster area. So of course, NHK has a helicopter to go there, but using such a crowdsourcing method, they can get a more timely and maybe more accurate, at least more timely data. And of course, in extension for the drone, we can use it for collaborative disaster response, collaborative search and rescue. So we don't know where the disaster happens, but if it happens, we can assume there are people there, people own drones, and we can task them on the fly in that way. So these are the two styles, Zipcar style and Uber style, to realize the drone net. Now, I have been thinking about demand, possibly, I mean, again, we don't have the data for the drones, but we have the data for the cars. So I use the data for the cars over time. Interestingly, over the past 8 years, the demand on cars in Japan is actually rather stable. So there are around 5 million cars. It doesn't increase significantly anything. However, what increases significantly is the car sharing idea. So you see from this figure that more and more people actually share cars, and membership is growing as well. Of course, the figures here are comparably very, very small compared to the owned cars, but the tendency is quite significant. Now, we can imagine, I mean, this development is a very recent. So for the car, it took maybe several decades from the owned car to the shared cars. In the case of the drones, this could happen in a very short time span. Actually, people wouldn't bother to have their own drones. They just, all the time, they would just share them quite easily. So this is one figure from Japan in the past. And this is a figure from the future, actually, and that's an interesting point, that for the car industry, this sharing idea plus technology poses actually a major threat. So if people don't want to own cars anymore, there is no increased demand to produce the cars. And moreover, automated driving, autonomous driving, and other services are becoming very popular and actually already taking place in some parts of the world. And in that case, tech companies are most likely taking a more advantage than the car companies. So for instance, Toyota actually noticed that very recently, and they built a new artificial intelligence, like a software research institute in Silicon Valley, including starting up with $1 billion up to $5 billion. So they're very serious to actually become a tech company. So now, this feeds nicely into my story about the drones. I'm not a drone maker, but we are interested in software, we're interested in artificial intelligence, and sort of comparing the cars to the drones, we believe people would share the drones, and also the business could be made with the software rather than the hardware, the drone hardware. So I said I would show a figure. So here's the figure. It's the future, and it's a global figure. And it shows that vehicle demand wouldn't increase much. So compared to the previous year, the next year, there wouldn't be more cars being produced. On the other hand, car sharing, the idea of car sharing would go up steeply. And according to this figure, we have by 2030, 15% of the cars on the road would be shared cars. So this is a second driver for the drone business. This is about electronic commerce. And the figure here shows the relative proportion of electronic commerce as part of the entire business to customer situation. What you see here is that steadily growing, people use electronic commerce more and more. Now, why does it matter to me? Well, I mean, it is known that for Amazon, 86% of all packages are below 5 pounds, which is a little bit over 2 kilos. So there's a lot of packages, but each individual package is actually pretty light. Yeah. So as you know, that the drone can carry payload, but not a heavy payload. Yeah. So actually, according to this figure and the estimation by Amazon, 86% of all packages could actually be easily delivered by drone. So electronic commerce, a good driver for the drone-based business. Of course, I can carry this on. So if we take increased e-commerce plus urbanization, the whole context is more accentuated. So here we can think about the last mile delivery by drone. As you know, okay, we have increasing e-commerce plus rapid urbanization. So more and more people want to go to the big cities, and the big cities grow, and the big cities growing means more negative implications of this trend, congested roads, pollution, decreased efficiency, and so on. Part of the problem is the last mile delivery, things generated by e-commerce. Again, using the drone, we could actually lift the delivery from the ground level, from the street to the air, and we can decrease traffic congestion, decrease pollution, and avoid all the negative aspects of urbanization. Another one is, I found this from the Japan Times. This is something which astonished me, so I wanted to mention it. It says that from 20% of first-time deliveries to your home fail for reasons presumably you're not at home. So in Japan, okay, these are the data from delivery trucks in Tokyo and Fukuoka. 25% of the whole distance those trucks, delivery trucks, travel are redeliveries, right? So I think here again, the drone the network of drones who can, bring you light items could help avoiding this problem of the redelivery, because as I said, the drone net, you can recruit local actuator resources dynamically anytime. So DroneNet will support completely flexible schedule for package delivery and returns. Actually, the returns are also interesting. So if you e-commerce, you get something, actually there's a mechanism you can just decline it, bring it back, and the drone can help in this aspect as well. Now, elderly, I have a figure here from the American service called Meals on Wheels. And it's about caring for the elderly. And according to the website, around 1/3 of the people over 60 years old, they receive a warm meal once a day by these Meals on Wheels. And of course, Japan and the aging population is a very severe topic. So we can imagine this helps as well. The problem is that this Meals on Wheels program is only partially supported by the government. So they are actually depending on volunteers. So volunteers go to these houses in the US and bring a warm meal. Now, of course, if the demand increases to having these warm meals, and we have only a limited number of volunteers, the system has a problem, and the government doesn't have additional money to support it, so drone can help the warm meal once a day, easily. Now, you might wonder what's the cost. So I cannot give a completely sincere figure here. However, I found information on Matternet, also kind of a drone net, and they estimate that for a delivery of 2 kilo over 10 kilometers, it's about San Juan. So I think it's cheap. Now, the next topic, I would like to talk about the situation in Japan, so because we're in Japan. So the good news is that there are powerful enablers. This is Prime Minister Abe-san. he established the Robot Revolution Committee, and they talk about how to use the robot in various aspects. One thing he was interested in is to support the drone industry. I mean, the situation is that Japan is behind for a very particular reason. For instance, in the US, it has a long history of using the drones, different types of drones, I have to say, for the military. So they have a lot of experience to do this. Japan didn't do that, so they have no experience, so they have to catch up. But Abe-san is serious to support it. So more concretely, there's an association, it's called JUIDA, it's the Japan Unmanned Aerial Systems Industrial Development Association. President is Suzuki Sensei from Tokyo University. And JUIDA is a kind of a mediator between the government and the industry. So they are very active in making a policy or driving the policy, because currently, or until recently, just 1 month ago, there was no law telling us where we can fly the drone and where we cannot fly the drone. So if there is no clear policy, obviously the industry cannot do anything, because they would work in vain. So this is Suzuki Sensei, and one of the results from, this is governmental, and I think JUIDA had some influence. This is now the regulation for airspace. So it means, in Japan, so it means we are not allowed to fly over the populated space. We shouldn't fly, or we are not allowed to fly over the airport, and we have to keep the drone below 150 meters. So other places, in principle, allowed to fly. Now, there's a more detailed information here, how to fly. Certainly the severest restriction here is that we still have to keep a line of sight. So this is not a real autonomous flight. It can be autonomous, but still there's a person who can look at the drone and see whether the drone is in a good, healthy situation. So this is the current status. I think it's not enough in terms of to really have a drone net, a drone air traffic, you need corridors, and the NASA started to work on this. So it's not like lots of drones in the air, like bees or birds, but there would be corridors where the drone fly and so on. So I think Japan also starting to think about it, and just yesterday was actually at the New Year's party of JUIDA, so I participated and had many interesting communications, among others, about this air corridor, but it's not completely understood who in Japan is actually responsible for this matter. This is also a recent information about Makuhari in Chiba, where the government wants to create a realistic test site. So it would be about direct delivery from the warehouse to some residential area. They used, I think, maybe Makuhari Chiba because it's an urbanized area, and at the same time it's at the coast, so they can kind of avoid flying over the populated area. And there's another slide on this. Everyone understands the drone as a live infrastructure can be very essential, important, and convenient. However, there are always three concerns. They pop up every time we want to do something with the drone. This is, of course, as I said, the legal issues. The aerial law in Japan forbids us to fly over populated areas, and this is definitely a restriction and a concern. Ethical issues. I think a response is similar to Google Glass. If you make a video footage of something, people would be very concerned about the privacy. So I think this problem is solvable. Obviously, if a drone flies over an area, it can take video footage. But from an IT perspective, there are techniques which are called real-time pixelization. It identifies there's something which has a privacy right and makes a pixel mess out of it in real time. So the story is maybe a little similar to what Google is doing with the Street View. They also have to concern about privacy. And the final thing is that the social issues, more we have to convince the general public that the benefit of the drones is higher than other inconveniences we can expect from the drone. Now, my personal effort currently is related to establishing such an industry, academia, government collaboration for drone research and development and innovation. So already I established the lower part. So my lab collaborates with a Japanese drone maker, and I attached a little startup. So we collaborate very smoothly. So I have the researchers and the knowledge about software, and they have the drones. So we help each other, and we can do the meaningful experiments. However, we cannot yet make a meaningful experiments in the real world. So we are now looking for local governments who might be interested to provide a test site, so like a living lab where we can, in a small scale, do a real delivery system in the real world using the local government. So we are now looking forward to the brave local government in Japan where can we make such an experiment. So I will move on to a different topic, which is a drone ecosystem and applications by drone. So the ecosystem here, I found this slide to the right on the internet, and it shows the several players. Of course, we have commercial, military, consumer, computer vision, delivery, marketplace, insurance, drone insurance, education and analytics and mapping. And this is a very busy slide from the international perspective, but actually I could not find any Japanese players. So I added some Japanese companies, but actually Japanese companies are now booting in day by day, right? The police came in with the net. Secom just came in with the drone, so I expect more and more companies. Komatsu, I should have mentioned Komatsu. Komatsu is collaborating with a US drone maker to scan the sites. They have many construction sites. So this is what we can expect as an ecosystem for the drone. I personally like the Internet of Things. You know, the Internet of Things is basically connecting some consumer devices to sensors. So in principle, you can use your smartphone app to check whether your fridge is empty or not. I'm not saying this makes incredibly a lot of sense, but the idea is that all items, things are connected in a consistent way, and it's typically about a consumer device, a smartphone, and some sensor. In this way, of course, the story works very nicely with drones, because drones are, first of all, sensors. And moreover, they are mobile sensors. They can go around like anywhere, and additionally, they can carry a certain payloads. So I think I expect the many good ideas, thinking that the drones as a part of the Internet of Things, sometimes called Internet of Everything or Industry 4.0. So these are industrial applications. So you can imagine from the pictures, energy infrastructure, agriculture, precision agriculture. So Japan was actually spearheading the usage of drones in the agriculture field. So the Yamaha's R-Max is around for 20 years. It's a helicopter. It's a little scary, I would say. But what this helicopter did, it basically spread some materials so that the growth would be encouraged. So when we talk about precision agriculture now, it's not about dropping the crops. It's about sensing the field and and identifying which part need a more attention or water and so on. So it can optimize agriculture. Of course, you can count livestock, police, obvious application, and all kinds of disaster-related situation. The drone is a very yeah, cheap way to do situational awareness on the situation on the ground. Now, this is just something I found on the web, that Paul Meissner, he's a vice president of Amazon, intends to initiate the drone delivery in Japan by 2018. So I hope some Japanese player would also be interested to do this before Amazon is doing that. And of course, the applications are very relevant for all areas which lack infrastructure. So this is one example by DHL, a German DHL, using drones to service a little island close to Germany, and they're actually running this with medicine, food, and so on. I think Japan has, of course, a very optimized infrastructure, but at the same time, Japan has many small islands, so I don't know exactly how these small islands are served currently, but this would be a starting point to service all the small islands by drone. And still, I believe the complete game changers would be places like India or Africa. India, no infrastructure and lots of people in need, and similar for Africa. Now, finally, I would like to talk about some research challenges. So things we're actually doing. So broadly, I can say that what we are interested in is to create new intelligence by human-machine collaboration using drones. So to make it conceptually simpler, I start with the car, the autonomous car. So as you know, the cars are now becoming more and more autonomous. Still, for legal reasons and other reasons, there has to be a human driver behind the wheel. So in the case of the car, the new intelligence created would be the situational awareness of what's going on around the car. So intelligence here means I know there's a pedestrian coming from the right, there's a marking to the left, there's a building, there's a traffic light, and so on. So this is captured by sensors, video sensors, all other kind of sensors, and that's how autonomous cars work. On the other hand, such autonomous or semi-autonomous cars are very good in the routine situation, everyday situation, but if something unexpected happens, you need to have a human driver to take control. So the research challenge is literally to have a situation of shared control between the machine, a car, and the human, the driver, and even a flexible control. And of course, it's currently not completely understood when the human driver should take over or release control back to the machine and so on. And so the human, the driver, would communicate and collaborate with automation, like ABS, automated brake system, is a kind of automation. And at the same time, it would control the car, the physical car. And the DL here means deep learning works for the car as well. Now, going from the car to the drones means we have one pilot who supervises multiple drones, dispatches multiple drones to certain areas to take disaster response, situational awareness to get ground truth of the situation. So here, the intelligence created is real-time situational awareness by the dynamic environment at the large scale, and the human interacts with automation. This would typically be an automated task allocation system, and the machine, the drone, would have on board a mechanism to in real time recognize objects, obstacles, and other elements of importance. So this summarizes my research, and I will go into individual parts now. So algorithm, okay, so this is delivery by drone as an optimization problem. This is a very expected kind of research, and actually this problem has been solved already. I just this is a mathematical formulation. I briefly show a concrete example. So we have a depot, take it as like an Amazon storage place. So you have 13 locations, 13 houses, mansions. You have to bring books, let's say. You have 5 drones, and the capacity of each drone is 10 kilograms. So each drone can carry books of 10 kilograms, and each of the locations have a demand of varying demand. So the first target here has a demand of 3 kilos. So the book you bring to this location is 3 kilo. Now, if you look at this situation, if you have some time, I think it's possible to find an optimal solution which respects some restrictions. So the payload cannot go over 10 kilo, for instance, and you have to service all the places. However, that's where machines and computers are really good at. So in no time, they would find a solution where each of the 5 drones has to go and deliver the thing. So this is not a research challenge. This is solved. However, if you think about a disaster situation, the situation might become more complex. In a disaster situation, new, let's say, targets pop up. Someone writes a Twitter message, there's fire, another Twitter message, another location says my building collapsed. So you might, in real time, have to retask your available resources, the drones. In one case, the drone goes there and gets a ground truth and checks whether the building really collapsed. So in disaster situations, using drones and social media, there's a phenomena that some people provide the honest information and some people provide a lie. They just say my house is crushed because they want attention and someone helping them, but actually they have no problem. So the drone can get the ground truth, what's going on in this area. So this is a research problem because we need to, first of all, the human might interact and set its own priorities, and the algorithm has to dynamically update its solution to a new solution. To support such activity, we are making a software. It's a kind of a HMI interface for drone supervision and collaboration with automation. And this is just a draft. So the idea is there's one supervisor, not a pilot, a supervisor, and let's say a ground control station, and sees all the drones in the air and can listen to the algorithm, where should the drones go, and can have his or her own priorities, what the drone should do. So this slide does not match actually to my big storyline, but I would like to mention it nevertheless, because there is one thing, it's about the drone service, using the drones for realizing your service. The other thing is servicing the drones. So if you have 100 or 1,000 drones, you have the maintenance problem. So we don't have the background into the maintenance of the drones itself, but we have a background into prognostics for jet engines, like the big ones, like from Rolls-Royce. And there we use engine health data. So prognostics means you predict the optimal time when you have to maintenance your jet engine. So if you maintenance the engine too early, you lose a lot of money, basically, because you did it too early. If you do it too late, some component might already be in a failure state, and that's very dangerous. So prognostics means finding the optimal future state where you should service your jet engine. So because you might have heard of big data helping us to do things better, and this is a classical case. In the past, people just look at the service maintenance history, and then they predict the next shop visit, that's how it's called, from that past information. Now, additionally, they include all these engine health monitoring signals. You can imagine inside temperature, outside temperature, vibration, and so on. So a jet engine creates a lot of data. This is streamed to the ground or the cloud and processed. And we have, using the real data, we could show that using those health monitoring signals, we can significantly improve the accuracy of the optimal next shop visit using historical data, obviously. And so having this success with the big ones, we also want to use it for the small ones. So this was a digression in a sense. So I'm coming back to the main storyline. So this figure shows something very important. What you have on the top is just a video sequence from the camera. This might be very familiar to you. The lower row shows each item annotated by a term that you can understand. Yeah? So you have road, sideway, building, sky, and so on. So I think this is what it's all about, why, for instance, Toyota spent this incredible amount of money in Silicon Valley to do something like this. It means your car or drone or whatever goes along, takes the video in, and automatically parses the scene. Parsing here means, this is a road, it's different from a building, you have to put a bounding box, something like that. Parses and labels it, gives it a semantic label, so we actually know what it is. And I think such technique has a tremendous application for the vehicle safety, first of all, and also for real-world situational awareness. You could almost imagine a blind person walking through the street, getting all the information by just the processing of the camera feed. So behind this magic is a new method. It's actually an old method, but it became popular recently again. It's called deep learning. Deep learning is a kind of a hierarchical learning. So it means you learn different levels of abstraction. Maybe, here we have the example of face and car. At the lowest level, you might just learn such a simple shapes. And then you compound these simple shapes to a little bit more complex shapes at a higher level of abstraction. And here, in the case of the car, you might identify certain components. In the case of the face, you might identify the eye or nose, ear, and so on. Yet on a higher level, you compound those concepts, and you say, okay, that's a car, and that's a face. And this can grow up and up, so you can identify a whole scene where people celebrate a birthday and so on. So this is an old technique, actually. In my 20 years ago, I read this book, but I did not understand the implications at that time. But this is a very powerful technique to automatically identify objects in real time. So you might ask, why is it happening now? Because the person who invented this, Hinton, he's around for 30 years, but he did not get a big recognition. What's different now from before? Three things. The first one is the GPU, not the CPU, the GPU, graphical processing unit. So now we have a NVIDIA Tegra superchip. It's a very small chip. We can put it on the drone, and it performs incredible processing power in real time. So that's why real-time object recognition. Second, big data. Basically, we have access to a lot of data because we can store a lot of data, and a lot of data are generated. So because to recognize in real time such objects, you have to train a model. And to have a good model, you need a lot of data. And that's what's happening now already. And of course, machine learning techniques like deep learning. Yeah. That's my vision here, and I would like to thank you very much for listening to my presentation. Thank you very much.
Okay, thank you very much. And there might be the Q&A session, but there are many things we have to ask. So before that, there's one person, he is doing the drone-based So do you have any comment?
Thank you very much for your presentation.
Thank you very much.
So I'm H. Sasar, and I'm focusing on IoT security.
Hi.
And maybe in case of develop ecosystem, risk-based approach is essential. However, there is no common measurement for cybersecurity or risk assessment. So, what do you think about the risk, so level of risk required?
Okay. So, I am from informatics, and security is actually an important part of informatics. At NI, we have Sonehara Sensei. He worked for NTT before, and he's now doing security work. So I cannot provide the satisfying answer. Obviously, it's a kind of IoT, Internet of Things. There's a communication, and people have to be careful about that these communications are not hacked. So, of course, earlier in the drones, like last year when these first consumer drones came out, there was a popular video. There was AR Parrots, like a French company, and it flies, and someone hacks into this and starts controlling the drone, right? So I think the security is a very important aspect. So it's not my research topic. So at NI, with the Sonehara Sensor, in Japan else, I think NICT is doing the security things. So that's all the answer I can give you. I'm aware of the problem, but as part of my lab, I don't have the good answer, but I'm confident people handle it.
So maybe regulators need some kind of common rules. And what do you think also maybe awareness about from risk in case of European people?
Right.
Is there any difference between Japan and Europe?
You mean the risk or the perceived notion of that drones can harm something?
Yeah.
Well, it's maybe too early to tell because many people are sort of surprised and they don't know what to do. I think in the US, I think many companies are bothering the FAA to do something concretely and tell us how we should deal with it. In Japan, of course, the president of JUIDA is a professor at the University of Tokyo. He's an air control person. That's where he comes from the big planes. And I think air control, geofencing would be one approach to look at this. If you ask me for the differences between people in Japan and in Europe, for that matter, I think Europe has also many countries and they are quite different. So my students from Southern Europe care nothing, and the more northern Europeans care more, I would say roughly. But what I felt in Japan, as I mentioned, the privacy is very important. Yeah? So they are very safety, security, and privacy. Yeah? So I think this has to be a focus and part of all the proposals we do, drone proposals, to emphasize this aspect.
Thank you very much.
Thank you very much.
My name is Michimi Muranoshi, professor of international politics teaching. I'm not sure if this question is a proper one, but as everybody knows, drones are being used by the military in many countries, like in Pakistan, like in Afghanistan. So I think there must be a lot of research areas already done by the US military. So, for example, in the last part of your lecture, you mentioned that you talked about the recognition of something from others. I think Americans would have already done how to recognize enemy from friends, how to recognize weapons from non-weapons. I think they are very important things for the drones, I guess. So, what is it that the Americans have already, US military have already researched and people who want to use it for commercial purposes need to know more?
That's an interesting question. There's a recent book published on the Predator. Predator, you know, this military drone. And also, by chance, last night at this New Year welcome party from Chuida, I met a person. He's Japanese, but he's from American company, from General Atomic. That's the company behind the Predator. This is this military drone. And now, because Abe-san opened the situation for business, they come just last month and make a new office here, and they want to sell the Predator, a military drone, to Japan. So I asked him the same question. What were the guys doing anyway? So what they do is, okay, they have the live video feed, and then they have a staff, and the staff looks at the video feed. It's a manual thing. So there's one person controlling it, and there's another person or more people looking at the video feed. And if they identify something interesting, they mark it in some way. They do not use the intelligent method. They don't. They don't. They look at video feeds and manually annotate. So they are not having any advantage in terms of the intelligence in that way. So he gave a concrete examples what they would be interested in. If they look at the sea is very boring, I think, right? I mean, if you just look at the sea. But they want to identify like submarine has a little thing looking out, and they want to identify such things so they can see, oh, there's a submarine. That's the example he gave to me. So to answer your question, of course they have all this lead time, but maybe what they're really good at is like some vision sensing technology. They can have a high resolution imagery, but I think Japan is not behind. I mean, of course, there's Sony, but they are more consumer cameras. They have really incredible consumer cameras, but usually the consumer is just a few meters away, right? I mean, to take a picture of. But for the satellite imagery, I think maybe communication and the robotic part, maybe they have a lead time. So this would be my answer. They don't have it. It's very recent. This deep learning is very recent. So they don't have it. Thank you very much.
Any other comments and questions?
My name is Hiroshi Tanaka, Professor of Project Management, with increasing focus on service innovation. I really appreciate and expect the jump social innovation benefit by the utilization of drone. You mentioned as possible drone application destination such as India, Africa. That's very interesting. I used to be in India, I'm now in the West Africa. And also, this is just my guess, drone may be useful in Ukraine, Russia. They have very good high technology in aerospace and aeronautical science. What is the current and potential limit of flight lengths? Because it's not easy to cover vast land like India, Africa. So that's my first question. And personally, I'm very much interested in what would personalized tourism look like. Because I have just completed my PhD's students study on service innovation in the hotel industry.
Right.
Because tourism part of that.
Right. Okay, so there are two questions. So I start with the first one, our India, Africa, and wide distance. So when I show the drone, typically I show a quadcopter or a hexacopter and can fly maybe 10 kilometers or 20 kilometers with a payload of 2 kilo, and because it has to come back as well, right? And this is just a one type of drone we always show the picture of. But for instance, the Professor Nonami in Chiba University, he's building what is called a VTOL, a virtual takeoff and landing. It looks like a plane,
Yeah.
but as part of the wings, it has a propeller. So basically, it starts by a propeller like a helicopter, and then it goes forward like an airplane with a backward helicopter, backward propeller. So. And there are many different ideas now. I think in Japan, fuel cell society something, maybe the fuel cell can also be working for the drone. I seen a person from US, he gave a talk at the Rakuten Tech Conference. He had a gasoline motor, which I thought is a little bit more scary. But I think there are many people, many smart people, and that's where also Japan maybe has a big history in just making really incredible, good, efficient machines. So I expect that in the very near future, we're going to have drones which can fly very long or short or can satisfy all kinds of needs. As to India, this is where we actually played a scenario on paper. I kind of didn't show it in the slides today, but we have a situation. It was the Khammam district in India. So there's a central health center, and the central health center has a capacity, human resources, and electricity. Yeah, it's also a problem. And this has to service sub-centers which can be spread out like maximum 150 kilometers. So for this to go it was the primary health center. The primary health center is maybe 10 kilometers from the sub-center. That's how it was. Yeah. There's another bigger organization which is 100 kilometers away. I forgot the term. I think a warehouse or something. From the warehouse to the primary health center, it could be 100 kilometers. So we need a big drone. But from the primary health center, services sub-centers. And the sub-centers are maybe just like 10 kilometers away. Yeah. And for each sub-center, again, you can draw a circle of like 5 kilometers where people from settlements can actually walk. So they would walk to this sub-center and get the health service. So from the warehouse to the primary health center, maybe 100 kilometers, but from the primary health center to the sub-centers, only a few kilometers, and that's where we can use the lighter drones, simpler drones. And so this also India. So, well, I mean, I can tell you, our contact, who is also, I think, Anikawa Sensei knows him very well, cannot get the permission to fly the drone. So the Indian government says, okay, to fly the drone, you need to bring up a story like delivery of human organs from A to B. You know, this is time critical and satisfies several affordances of the drone, but we cannot do this. This is too serious, I would say. I cannot do such thing. The second question, give me a hint.
It's personalized.
Yeah, exactly. Yes. So this is something where my students always get so glowing eyes. And what did we have? I mean, for instance, a simple example is if you have Nagoya Castle, you can have a drone going around over Nagoya Castle, and the drone can have a 360-degree camera, and then you sit at home with your Oculus Rift, you know, these virtual reality glasses, and you go to the left, and then you can turn the camera, you see the view to the left or to the right. So one example I always brought up, but no one was interested in, for instance, the elephants in Africa. Yeah? I think for me or for many other people, it's maybe difficult to go to Africa in the you know, it's a little dangerous too. But I would be really interested to see an elephant or lions really close up, right? Okay. So if there would be let's say a little company in Africa with some pilots, and the pilots kind of hover over the elephants, and then I recruit this drone and the pilot, and I can even instruct him or her, go here, go there. And this is a personalized tourism. I like that.
Very interesting. Thank you very much.
Thank you very much.
Thank you for nice presentation. Okay. My name is Natori. First of all, I'd like to apologize to you that I missed most of the part of your presentation. Okay. But however, you mentioned about research and maintenance. So that I want to ask you that two things. Okay. First issue is research. You showed us the delivery problems. Okay. And your examples looks like mixed integer linear programming problem. Okay? But however, to apply the drone to the real world, okay, we have to think about many things. For example, to avoid some of the important secret area. In that case, the drone have to make a detours. Okay? In that case, okay, the problem becomes from the mixing linear program to the non-linear and mixing the non-linear programming. Do you have any plan to solve such type of the problem?
Well, I think, okay, so this routing problem, or which I called task allocation, literally means you have an area and you have a target. You have to go here and you have to go here and to go here. So what we use in our research is it's called distributed constraint optimization. We've reframed the delivery problem, distributed constraint optimization problem. We completely abstract from the detailed routing things, right? This is actually, it just means you have to go to that point, and we don't care actually how you get there. So this would be taken over by a different mechanism, literally. I had a student, he did like, you know, if, in our case, delivery, the sky is rather open. There are other people, they work on, for instance, a disaster case, some drones should go into the building, right?
Yes.
And they have to do the path planning in the building, and they in real time have to recognize the obstacles and so on. So this has other requirements. So to answer your question, I think where we are working it is a very high level, but we could use linear programming, a distributed constraint, max sum algorithm. So there are many algorithms which could be applied. It's just getting difficult, you know, if you have to dynamically readjust your plan and find a different solution, and then you need some heuristics or other methods. But yeah, as to the actual planning, we don't have any detailed knowledge. I touched it when I said, okay, we can recognize some target. That's what I said, but I didn't say what we do when we recognize it. Yeah, we have to avoid it in some way. It's perfectly correct. Again, maybe more like a robotics problem.
I think if you have a chance to look at to apply the mixed integer nonlinear program, the solver, okay? I think that the delivery problem will be able to overcome. Okay? That's my observation. But however, okay, to do this, okay, more important is that's your second question, the maintenance. You mentioned about the prognosis.
Right.
Now, for both of the diagnosis and prognosis is very important. But do you think the currently available sensor or some of the systems such as deep learning might be enough for us to effectively, safely, reliably utilize the drone?
Oh, okay. So as to the prognosis, so what I can say is that, so we have the data set from Rolls-Royce, jet engine, and Embraer, like a Brazilian machine maker. And this is a kind of a big data analytics. So they have many values. Actually, I have to say, honestly, I know there are many values, but I don't know exactly what they mean, because it's, again, we cannot access all the detailed data because they are scared, because I can just go to Mitsubishi and say, oh, you know, so I don't know. But what we know is there are lots of data, and they are taken at high frequency. And kind of the claim of big data is, as long as we have big data, it's going to be all right. So because, you know, part of the success of big data analytics is that as long as you have a sufficient amount of data, you cover all the possibilities. So this would be a safe way to predict. And actually the big machines, they would in real time send the data to the ground, and the ground station is doing from the real passenger airplanes, and they do their calculations. So this would be a question about is big data analytics sufficient? It's a kind of not model-based, it's more like big data-based. Yeah.
And what I want to say is that in case of an airplane, there are so many sophisticated sensors available. Okay?
Right.
That by capturing the huge amount of the data from the sensors, that probably we'll be able to analyze the condition of the engines.
Right.
But in case of drone, that we have to focus on some point. So far, I have checked that after I checked the quite few numbers of papers about drones.
Okay.
But there are so much scientists or researchers who might be familiar with the maintenance of the drone.
Right.
Therefore, I ask you.
So okay, now maybe I have maybe a better answer for you. So if you buy a drone for Niger Mayen or Sandra Mayen, I think they can have sensors as well, but maybe it's not sufficient. On the other hand, at one drone expo last year in Makuhari Messe, I walked up to a company. It's called Ariane. It's a Canadian maker of military drones, but not a big, small. It was maybe that small. 1 meter, just a military drone. Looks like nothing, yeah? And then I say, what's your drone cost, yeah? And it was like, I don't know, $1 million or something. I said, what? Your drone is $1 million? Looks like nothing, yeah? So he said, it's a military drone. A regular drone, like which you buy for Niger Mayen, if there's a wind, the drone already has a problem, yeah? But in this case, in this very expensive drone, he says they take sensor data, I think 50 times per second, and they analyze it in real time, so they can stand incredible wind bursts, for instance. So it's a very highly reliable drone, because the mission of the drone literally is go to the enemy's place, check up, and come back, right? And anything can happen over there. So it's a little bit, again, maybe to answer the question more positively, the sensors are getting more and more better and more cheaper. So I expect even the cheaper drones, not military drones, can have more sensors, and more sensors lead to more reliability, because we don't have to worry about the analysis, even if the amount is big. So that's a kind of answer.
Thank you very much.
Thank you very much for your presentation. My name is Hiromi. I'm currently in the MBA program here at KBS. I like the idea of Uber for drones a lot, and I think it will come someday. And my question is that you mentioned that the collaboration between local government and drone makers and researchers like you are quite essential to test drones. And you mentioned that Makuhari is already doing that, or are they already doing that?
Makuhari, no, they are not doing it. I confirmed yesterday, not doing it. This is a governmental slide. I shown you a slide from the Japanese government. It's not a local government from Chiba area. It's a governmental slide. So this is something they want to do, but not doing it. They are. It's a slide.
Okay. So would you say all these Japanese local government will be interested in giving a test field for drones, or if not, then is it going to be like social reason or ethical reasons, or?
Okay, so maybe I'm not so good to answer this question, because I not directly communicate with the local governments in Japan. I think what I can say is that one of the problems in Japan is that all the people go to the big cities, so the rural area become like deserted. I mean, there are not many people there, and only old people are left. So I think the local governments have some interest to revitalize these areas and make some business there. So the drone is one item where they think this is a new technology and maybe we can do something in our rural area. So I can only give the one. Unfortunately, I didn't show the slide, but we have been informed that, for instance, Nakacho, Kagoshi Prefecture, Nakacho, is a kind of a peninsula island. So there, they announced they would do something. It's a local government would do something together with drones and some industry, but already the project maybe already established, so there was not. Other than this, I cannot give a good answer. Maybe it's more administrative. You don't know to whom to talk to. Yeah? so it's as simple as that.
Regarding to the experimental side, in Japan and the foreign countries, Dr. Sasara may have some kind of the suggestion or knowledge.
Yes, as you know, Danish government developing a license for drone.
Right.
And also, I'm interested in local government, in particular Kawasaki City government, because Kawasaki City government developing MOU with Odense in Denmark, and Denmark Odense is focusing on commercial drone businesses.
Right. Okay.
Is there any your recommendation to Kawasaki City government?
Yeah, we will note it down and we follow it up. So it's not like I cannot fly the drones. Yeah? So actually, I have a PhD student in Thailand. He's at the Asian Institute of Technology. This is 1 hour north of Bangkok, and we actually, my students, they go to Thailand next month, and we're gonna have multiple drones flying and make a real test at the AIT campus. Also, my student is now getting the license to fly the drone in Bangkok. Yeah? I'm very surprised about this, but he will be able to fly in Bangkok. Yeah? So, but then again, I have the student there, and we can go there. That's fine. But I'm in Japan, yeah. So I'm more interested to make a progress in Japan.
So virtually, flying the drones in the urban area is prohibited.
It is banned unless you have a specific exemption. So I think in this Chiba case, this is populated, but they have an exemption. They can fly the drone, but still, you know, it's a half. It's a compromise because they are not flying over the houses necessarily. Maybe they go along the coast path. Yeah, so that's maybe the idea. Again, sorry.
Is that enough? For example, that you wish to make an experiment of long-range network of the drones. So maybe the 100 kilometers in diameter was that kind of the huge area is required. But even if some local government allow you to fly the drones, but you need more space. No?
Well, I mean, it depends on what kind of situation I want to do. If I want to simulate a disaster situation, a drone network literally means like a Uber. There would be drones all around, right? And I just task them.
So you don't need space quite a lot. So
No, I think, I mean, if it's on the, first the test, if it's on the level of 10 kilometers, I think this would be good enough. So what we have in Thailand, I think this is 4 kilometer by 2 kilometer. This is already enough. So for the first test, we are not testing the endurance of the drone. We are literally testing the service. Yeah. So we could do it maybe even if we have 100 meters. Could do. Yeah. 100. Okay. Depends on the GPS signal. So.
okay. So continue. I interrupt your answer. So is that all right?
Okay. So maybe what I want to say is again. what needs a progress is to regulate the airspace, and maybe just because I'm interested in drones does not mean that my vision is that I can fly the drone everywhere. Yeah? So I don't want to do this. What I want is that regulators or the government or someone identifies areas where we can fly. So a nutshell would be, if there's a river, why not fly over the river? Yeah? If the drone goes down, it's in the river, not a big problem. Or like some streets. So on the ground space, we have a street network, and we have regulation how we can use the street network, but in the air we don't. So if we had corridors, I think Amazon, actually that's what they did. They applied for a corridor in the air. They just say, okay, between whichever 100 and 120 meters, that's us. We want to fly there, yeah? And we have our system. Maybe something like this. This indicates a corridor. So it's not about flying all over the place. It's about flying in a systematic way.
Okay, the problem of for example, this is a Keio University Hiyoshi campus, and enough space to fly the drones.
Yeah.
And especially that is the huge background here. But 1 year ago, the one student did the research on the drones,
Right.
and flight, and he missed that drones, and that drones fell the Shinkansen line. So it was so disastrous because it would stop the Shinkansen, and so somehow it is very significant, even if this is a spacious area. But next to the space, the Shinkansen, or very important line, is connected. And so the regulation, in spite of the regulation, the Prime Minister Abe announced, still there are lots of the legal and regulation issue prevailed. So did you detect some progress after the Prime Minister Abe's announcement?
Yeah, well, I think this is maybe not a fast process, and it's not like it's a slow process in Japan. It's also maybe a slower process in the US. And in Europe, there are other things like, I think Europe is maybe a little bit faster, and we saw it in Denmark, because the European Commission always identifies how can we make the future business, and to make a future business in this low altitude airspace, we have to regulate it. And of course in Japan the situation is like, if you're in Japan or you're on the sea, right? So, but in Europe you're easily in one country and then in the next country. I mean, there are places like Liechtenstein, you don't even notice you went through Liechtenstein because it's so small, right? So they are very eager to have a consistent system. So if a drone flies, it can also fly to the low altitude airspace of some neighboring European Union countries. So maybe they would even be driving faster. In the US, it's the FAA, and the FAA is not so fast, but there are strong lobbies like Amazon, Facebook, Google, all pushing. And still, I think what I felt is that Japan, the government thought, okay, we are a little bit behind with the drones as a robot, because they don't have the military background, but they could be spearheading in terms of legislation that actually we can do it in Japan, right? So Japan would be the first place where it kind of works in a realistic way, and that would be a great success. So I'm unfortunately not in a position to actually push the government, but I think the people are seriously, maybe you can push the government more easily. So, or you can push the government more
Two
easily.
application area prepared in Japan is one is some kind of the detecting and the monitoring the natural disaster over
Right.
forest and volcanoes and area afflicted by the earthquake. So that kind of the application would continue quite easily.
Absolutely. So there is even, I think, SIP. This is a cross-governmental, huge research project on tough robotics, TAFU robotics, I think that's how they call it. And Fukushima, of course, they noticed that if there's a real disaster, the robots are not in place. So I don't, and many people are involved in, our collaborator is also flying in Fukushima, no problem, yeah? And volcano, no problem. But so what I, from my IT background, I want to consider the big story for the daily life, not the disaster. Yeah? Of course, if we apply for the research grant, we talk about disaster, because then we can get the money. But generally speaking, I would be so much interested in including the drones as part of the common life, take a part. Yeah? And for this, I need a realistic environment which has houses and people who use the drone and so on.
Okay. For that purpose, to use the drone in the daily life, as Dr. Sasahara mentioned, there is a special government treatment, special district regulation, like Kawasaki City or Yokohama or Tokyo.
Yeah, yeah.
So Makuhari might be the part of that kind of the special district.
Yeah.
So that kind of experiment is possible. So that might be the reason. And also the Makuhari experiment, the delivery system.
Right, absolutely.
Is forecast. So delivery companies might be very interested in, like Domino Pizza or that kind of. So, or Japan postal systems. So would you? Do you mentioned some kind of the figure, who are the participants, but there is no delivery Japanese company.
No, there's so what I did is I talked to the key drone makers who should know about it and have close relations to the government. So particularly en route, our collaborator, and Nonami-sen from Chiba University, but they cannot give me the detailed information. Okay. They don't know it. So they say something is going to happen, or Suzuki-sensei, but they don't know when and how. And at some point, I also understood that Amazon, Japan, was very interested to be part of the story, but then it was blocked out, or I think there are many things going on. So for us, it would be important to find any chance to actually do something.
Any suggestion from the floor regarding to this program? Whom he should persuade, or whom he should talk to?
Yeah.
Any suggestions?
There is no suggestion. I think, how about Iwata-ken? I'm interested in Iwata-ken in this respect. I think the eastern part of Iwata-ken is so isolated from the western part. I think, even though there may be roads. So I think traditionally, I think the mountains between the east and the west of Iwata-ken is such a big problem.
I think so. My experience is it's very easy to think about situations and places where it would make sense. So my feeling, what's missing from my, I just work at the university, have a lab, is like who to communicate to, who to convince. So if we talk to local government, I think those are not people who are sitting there and they get totally excited that I say I'm going to do the drones now in your place, yeah? Because such people typically try to avoid any inconveniences. So maybe what's needed would be more some prominent person whose voice is heard, and they would say, oh, okay, if this person or this university is saying it, maybe we should do something. I think this is not a bottom-up process, it's a more top-down process. So maybe if Abe-san says it, people would wake up and say, hey, okay, so we should do something, right? But unless it really goes down to making something concretely, it might take a while. I talked to the drone makers, Japanese companies, and other people who should have the influence, but also they are looking back at me and say, maybe you can do something. So it seems that many people are so much excited to get it done, and they look around, and the news, every day we read something, what's happening or what should happen. But to make it so if Keio University says this is a good thing, that's how it works, I think.
Maybe there are so many local government leaders who might be interested in
right.
your project. But some kind of the issue you mentioned or you raised, security issues
Right.
and risk issues and perception and
Right.
acceptance from the public.
Yeah, exactly.
So when they think about that kind of a possibility, they are refraining from being very aggressive. So maybe there some kind of the infrastructure for the public acceptance might be required. Legislation or regulation or so that kind of the
Right, that's correct.
social infrastructure.
Regulation and also registration also was what Japanese drone companies are doing, and actually JUIDA, this association, as a future milestone, is training pilots to fly the drone, right? So educational program. This is, I think this is what they are thinking about. My approach would have been, I look at some particular area in Japan and I try to understand some limitation, something they have a problem with. So the simple example is always like some elderly people in a remote places or at some island, and then I can ask, okay, how are you solving your problem, right? I mean, how do you get there? Do you take a car and a ship and everything? And then if I see a concrete problem, then I can convince, and they would say, oh, okay, because local government has a shrinking money, because the people go away, they have a less tax, shrinking money, maybe more problem to service the people. And health care, I think it's a local government problem. So that would be my approach, just pinpointing, okay, you seem to have a problem here, we can help you, and to get a public acceptance, of course, people are not just putting drones in the air. There's some that people are informed about what's going on and they can participate.
So one more additional comment is like this. In order to accept this kind of the service in a broader sense, so some kind of the insurance or damage control is required. Is there anyone who comes from the insurance companies? No? So product insurance or damage insurance,
right,
or that kind of so that might be the important issues in the future. Not now, but
right.
So any other comments?
Yeah, insurance.
Of the insurance? There is no insurance at this moment. The drones experiment is covered by some kind of the insurance at this stage?
Well, we figured it out. So there was an insurance, I forgot the name, but we could insure the drone, but not if the drone creates a problem by itself. I think that was there was actually an insurance.
Oh,
there is an
really?
okay. To say it more precisely, like for instance, the drone makers. When they sell the drone in Japan, they sell a whole package. So the package includes basic training of with the drone, flying the drone, maintenance of the drone, and also some insurance. So I think it was not so expensive. It's maybe 5% of the whole package for the insurance. But I also think that in terms of a business, insurance can be a major thing.
Okay. So another final question is like this. I raised this question personally before.
Right.
You are doing research on the artificial intelligence and software and mathematics. And you can use your knowledge and understanding to the field other than drones. For example, you mentioned auto driving or so Uber-like taxi service and matching of the workers, temporary staff, or that kind of thing. So why do you choose drone service among those kind of the possible potential applications?
Yeah. So if it was a personal question, I can give you a personal answer. So actually, originally, my idea was to make some technology for automobile in Japan. So for many years, I tried to appeal my research to the Japanese car makers, and I had some interactions. However, nothing ever happened. So, so always I get a warm welcome, or thank you, you have an interesting presentation, and then finished. So although I kind of had a connection to high-level people, actually, and then I say, all right, let's do a research proposal together. You're just my partner. But for instance, I mean, the big Japanese makers, you can imagine, there are a couple of them, but they don't do such things. They simply, I'm too small, and they are too big. I mean, if you take a company like Toyota, it's its own country, right? So if they want to do something, they cannot do it anyway. And if there's something interesting, they buy it. So they are not collaborating. They are not collaborating. They are very conservative, and many people try to collaborate, but it didn't work. So I was looking, literally, for a business which is not too big and not too small. And the drones...
At emerging stage.
Emerging stage. So the Japanese drone makers we collaborate with are perfect in a way that they make a drone, but there's a small and medium-sized business. They cannot afford having their own R&D center or a research center. They are not that big. So now there is a match, and this makes it very attractive for us, because we can collaborate with a company, and the company kind of needs our expertise. Yes. That's one reason. So many things came together, actually, with the drones. It's an emerging technologies. Japan just starting up. 2015, last year, was called the year of the drone in Japan. That's where it all started up. Mm. So now I feel so excited, because now it's just starting up. Yeah? Okay. Either it's too early and no one wants to listen to it, or it's too late and everything is set up already. So it's just now I have to do something.
but still, I think you are too quick. So 5 or 10 years ahead of the time when you pursue the auto manufacturing companies. But this is the right moment. You can pursue it again. Yeah,
absolutely. That's perfectly correct. That's correct.
So the drone might be very difficult problem because of the security issues and some kind of privacy issues and regulation and legislation. So many problems are included in drone service. So I suspect you pick up the most difficult area. No?
Right. Yeah, it's definitely the most dynamic area. So, I still, and I have, this is a fact. So for instance, I talked to Toyota, right? But Toyota established the research center in Silicon Valley and not in Japan, right? This is also very strange, I think.
Ask the different companies. So that's okay. Any other final remarks?
Oh, just for information regarding insurance, fintech or fintech startups in the U.S. Are trying to utilize drones for inspection of accidents in rural areas.
Right.
They already started. So, from my perspective, it could be better for you to talk to SMBC or MUFG or financial industry.
Right.
They are very interested in drone.
Perfect example, actually. I mean, that's exactly Internet of Things smartphone app, because if there's an accident, you have the GPS location. You can automatically task the drone to just go to this GPS location, remote GPS location, and take the picture and video footage. It's a perfect example. Insurance, yeah. So insurance, yeah, maybe so. That's good.
Okay. Thank you very much.
Thank you very much, Domar Ismail.